The last section in chapter 9 is about what to do when you have two polar curves and you're trying to find the area bounded by those two curves. So if you have an area that is strictly between two curves, like if I want to know the area of kind of this moon shape that's outside of the cardioid and inside of the circle, then we're going to subtract the two areas. So we would do 1/2 times the first radius squared minus 1/2 times the second radius squared. And the first radius squared would be the one that's farthest away, just like we did when we were subtracting the area in rectangular coordinates. So what we would essentially be doing is we'd be taking the integral of the first curve, that we'd find that area using the area formula for polar, and then we'd do the area of the second curve and we would subtract them, so we're left with that moon shape. I want to emphasize that this is not all that could happen when you have two curves. Your two regions might be side by side. It might be a mix of one of them is on the outside and one is on the inside, and they're also side by side. But we'll look at that a little bit more later. So we first want to look at we're just going to write an integral for the area inside of 8 sine theta and outside of r equals 4. Well, r equals 4 is easy to graph. So r equals 4 is going to be a circle with a radius of 4. So that just means whatever theta is, the radius is 4. 8 sine theta, we can kind of get some points and figure out what the 8 sine theta would be. So, and I'm actually, I'm going to back up a little bit. I'm really curious where they cross, right? Those are intersection points. That is so interesting when we're looking at area. That's the alpha and the beta that we're going to be looking for when we set up our area. So let's go ahead and algebraically look at when they would cross. So that would be when 8 sine theta is equal to 4. When the two curves are equal is where they cross. So that would be when sine theta is equal to 1/2. So that would be when theta is pi over 6 or 5 pi over 6. So at this point and this point, our curves are going to cross. And I don't know if you know, but 8 sine theta is a circle. It's just not a circle that's centered at the origin. We would start at 0, and then we would go out here. And then when we got to pi over 2, we'd be at 8. That's not a very big circle, but you get the idea. And then we would be coming back to this intersection point, and then we'd go back. Why is a circle so hard for me to draw? You know what I mean. Something like that looks more circular. And then we're going to find the area inside 8 sine theta. So inside this circle and outside r equals 4. So we're looking for this area here. Really, I was just starting to shade. That was what my problem was. That's why I was so messy. Okay, so what we're going to do is we're going to take the integral from pi over 6 to 5 pi over 6, which are the two intersection points that we found. And we're going to do 1/2 times 8 sine theta squared minus 16. We are our integral. This is definitely not something I'm asking you to calculate without using a device. Before I do another example, here are some of the artistic creations that you made for your ABA. The other day I asked you to make something beautiful with polar, so here are some of the elaborate designs I saw that you made during that activity. So here's another example. We're going to write the integral for the area inside both 9 sine theta and 9 cosine theta. These are both circles again, and I want you to look at the regions we're talking about. We're talking about this overlap area of kind of the Venn diagram overlap, and for this one, there's not a subtraction that's going to happen because these curves are not like one is not farther away than the other. It's that we're going to be using the sine graph first, and then we're going to switch over and use the cosine graph. So this is also one where we want to see where they cross. So we'll go ahead and do that. So we're going to say 9 sine theta equals 9 cosine theta. So they cross when sine theta equals cosine theta. So they cross when theta is pi over 4. So that makes sense on our graph. And then we're going to start at theta equals 0. We already looked at this 8 sine graph. It's going to be the same for the 9 sine graph. So when sine is equal to 0, I'm going to do the integral from 0 to pi over 4 of nav 1/2 times 9 sine theta squared. But then we're going to add, because these are not, like, I'm not taking away anything, I'm going to do 1/2. And I want where I'm going to start at pi over 4, and I'm going to end when I get to 0. So I'm going to start at pi over 4, and I'm going to end at pi over 2. All right, for this last example, I'm going to have you try it. Pause the video and restart after you've tried it. The first step, again, is going to be to figure out where these two curves cross. So start there. 1 equals 1 plus sine theta. So they cross when sine theta is equal to 0. So they're going to cross at theta equals 0 and pi. So those are our intersection points. And then so then we're starting here at theta equals 0, and we're going to end here at theta equals pi. And we are, in this case, going to be subtracting because we're trying to find inside the cardioid and outside the circle, so we're trying to find this region. So we're going to do the integral from 0 to pi of 1/2, and we're going to do the cardioid first. Minus 1. And the area, so we would for sure be using a calculator to find the area, and so it looks like the area is 2.785. I want to point out that I typed on my calculator, I typed a theta, but you definitely don't have to. You could do this same integral with an x, because remember, this is a dummy variable. It's not a variable that really matters what letter you use, because your final answer will be a number. All right, that is polar area between two curves, or maybe, if, in this case, when two curves are side by side. Okay, have fun.